Welcome to the Good Ideas Club, where big ideas spark even bigger conversations. In this episode, we sit down with Areiel Wolonow, 35 years deep into emerging tech. He's led teams behind 𝗵𝗂𝗁's AI credit engine, he's delivered IBM's first ever blockchain project, and he's helped build Google's AI risk framework. We asked him one question that no one's been able to answer yet. What happens when quantum computing, AI, and blockchain technologies converge? What followed was an absolute masterclass, from 12,000-year-old clay contracts in ancient Sumeria to the quantum resilience crisis hiding in your software today. If you've ever wondered what agentic AI means for your future, Q-Day for your data, or how blockchain solves some of the biggest problems older than writing itself, this one's for you.
Areiel, it's fantastic to have you on the Good Ideas Club. Thank you for your time this evening. And can you start by telling us a bit about yourself, please?
Sure. It's delighted to take part. Thanks for having me on the show. Yeah, so I've been working in emerging tech for my entire career, which is about 35 years. Started in 1990 in Silicon Valley, right at the start of the dot-com boom. I worked in the Valley for about 10 years, then started living abroad, first in Singapore, then relocated here to the UK, which has been my home for 20 years now. Spent a good number of years at IBM. Latter part of that time, I spent building new services practices for them. So I launched IBM's financial service practice for the East Africa region. In that role, I led the team that used AI to build the credit engine for 𝗵𝗂𝗁 in Kenya, which is, if you aren't aware, is the most penetrated mobile money solution in the world. 40% of the Kenyan GDP flows through it. And it's a country of almost 50 million people, so it's non-trivial. Then went from Nairobi to Singapore to launch IBM's blockchain practice for the ASEAN region. Led the team that delivered IBM's very first blockchain project, which was a prototype for letter of credit origination for HSBC and Bank of America that was underwritten by the Monetary Authority of Singapore. So in 2016, I sort of took stock and said, okay, I've now launched successfully 2 practices for IBM. What would it be like to launch my own? So I did that, and I started a consultancy called FinServ Experts. I grew it from a one-man band to about 18 people, which is what it's at today. And our focus continues to be on emerging technology. Some of the projects we've done are for some larger clients. Google asked me to help build the AI risk management framework for their own AI go-to-market team, led the blockchain trade settlement prototype for Lloyd's of London insurance market, and was asked by Deutsche Telekom to design the German blockchain ecosystem. Done a number of interesting things, but more fun, I would say, and potentially more relevant is the work that I've done for small early stage startups. It's important to do the large corporate work. It's a scope of problems that you won't be asked to solve anywhere else. And quite frankly, it allows you to build some brand credibility. But the real innovation is happening in the smallest companies, by and large. So, I worked with the UK fintech Finexos, which is using AI to enable credit for people who can't otherwise access it. Did some work during the pandemic with Block Bioscience, developing the only health passport that got the ID 2020 certification for self-sovereign data. Working on a blockchain for sustainably grown seaweed in Indonesia. So a lot of different.
Incredible. And the reason you're on the podcast today is, again, LinkedIn worked this magic and connected us. And I saw in your bio or in your kind of header that you were an AI quantum and blockchain specialist. And that's exactly what I've been looking for. Alex will know. I've asked so many guests on the show one question in particular, which I'm going to open with you next. And to be fair, people have been humble enough to say, I don't feel comfortable talking about that because I just do not know about, and it tends to be quantum is the thing that trips people up. So I'm so glad that you were willing to take the challenge on. And my kind of question has always been, with innovation, we always look at the here and now, like what are the latest tools that we can use right now? But I like thinking about innovation in the future and what are the so whats? What are the long-term impacts of the things and the emerging technologies that we're experiencing and talking about now? And obviously the distraction right now, everyone is so hyper-consumed with AI that not many people are kind of looking beyond that, I think. And so my question is, what does a future look like where quantum computing, AI and blockchain technology, not necessarily crypto, blockchain technology, What does the future look like as a human being on this planet when those three technologies have stabilized, emerged, and become part of everyday life?
Well, it's a fantastic question, and I think we're probably going to spend most of our 90 minutes answering it. It's not a question we're going to arrive at quickly, which is
Good.
not to say I don't have an opinion. I do. But with your permission, I'd like to break that down into a couple pieces
Absolutely.
to talk about where the capabilities of each technology on its own are now and are likely to go, and then start talking about your early, middle, long term, how those technologies can be used together. I want, before I even do that, I guess there's two things that I want to start. They're in the ways of qualifications or disclaimers, if you will. You had said that that everybody felt shy. I don't feel shy about expressing opinions about quantum computing, or blockchain or AI for that matter. But in terms of operational use of quantum AI, it's true that there are no experts. I certainly don't claim to be one. I started teaching myself quantum mechanics and the fundamentals in 2019, and then as the leader of a consultancy that's focused on emerging technology, that's my job. Anything that I work on is going to be stop being emerging and start being mainstream within n years. So I need to always be ready for what is the next emerging technology. So in 2019, I made a bet in terms of taking a gamble on how to invest my time on what the next thing was going to be after AI, and the bet I made was on quantum computing. Seems likely that I could be right, but by no means guaranteed. But even when you get beyond quantum and start looking at blockchain, so I've brought 6 blockchains into production, none of them crypto based, by the way. And I can tell you for a fact that we're still making it up as we go. I'm not sure there are blockchain experts, the way we normally tend to think of the term of expert. And, blockchain is certainly more mature a technology than quantum computing. So I think the statement that, that you're not going to find experts is true. It's not to say I don't have opinions, but I think that is the reality, is that we are all just figuring out how these things work. Arguably, you can have more proper experts in the field of AI because a lot of the math is not new. So my educational background is in econometrics. I got my bachelor's degree in 1984, and learned a bunch of math that I thought I would never use. Fast forward to 2014, and I'm working on the 𝗵𝗵𝘁 project in Kenya, and I've got several PhD data scientists from IBM Research Lab. I didn't think I would ever become a PhD level data scientist, but I wanted to at least understand them. So I said, "Look, let's take a half day, and I want you to teach me how these models work. I want to understand the algorithms. I have enough technical background. I should be able to understand this." So they start walking it through me, and I realize it's the same math that I learned when I was learning econometrics in the early 1980s. It is various forms of regression. The only difference now is that, you had to make, in the early 1980s, you had to make guesses and then see how well your guesses fit. Now the computer can optimize the fit by determining how many, and all you have to do is set the limit of polynomial depth that you want to go into in terms of establishing that fit. But the math is old, and the techniques that you are using to do predictive modeling, so the supervised machine learning side of AI go back to the 90s. So I think in AI, arguably, you can have proper experts, people who actually understand this in depth. But in blockchain or quantum, no, we're still figuring it out as we go.
Okay.
The second qualification that I wanted to make is one in terms of my bias, which I think limits my effectiveness as a long-term futurist. And again, not to say I don't have opinions, but when I started FinServ Experts, I did it to address a pattern that I saw in emerging technology my whole career. It's happened with the internet, with the web, with mobile, robotics, AI, blockchain, which is this amazing emerging technology that has the opportunity to change our lives for the better, comes into being, through the hard work of some brilliant innovators. Companies spend tens of millions of dollars implementing these new technologies, use them to re-engineer their existing business model, And even when the projects succeed, which they often don't, they're left scratching their heads because they don't deliver any value. So to my mind, and the focus really is not on the tech itself, but on the business model the tech enabled. If you look at the great innovation or disruption success stories, of the internet era, Amazon, Uber, Airbnb, it is not the tech that caused the disruption. It's the business model. Amazon, you can get anything you want delivered to your house within 2 days. 1 day if you're in the UK, 2 days if you're in the US. Uber, no more waiting for taxis. Airbnb, all of these things, it is the business model that the tech enabled that has changed our world, has changed our life. So in asking the question, I can't tell you how many people said, I'd like to hire you because I want to do blockchain, because I want to do AI, and I'm left scratching my head. So when we think about what the world is going to be like, to my mind, I'm less interested in saying, in 10 years, quantum networking will actually be possible rather than just an idea in scientists' heads. Well, that's fine. What does that mean? What is it going to change in terms of how we live, how we work, how we exist on the planet? Does that make sense?
Yeah, I'm following so far. Yeah.
So all of those caveats, I think that, as I said, I think it probably behooves us to talk about where the technologies are. AI is broadly, and this is hopelessly overgeneralizing, but tend to break down AI into old AI and new AI. So traditional machine learning has been around the longest. It's been around in a usable form since the early 2000s, and its potential has not even remotely been tapped and has been largely unlocked by just greater and greater processing power as we've gone through. But we're by no means saturated the ability of people, companies, governments, universities to derive value out of, shall we call, classical AI applications. And then, of course, we have generative AI and large language models, which have exploded on the scene, given rise to, hype curves all their own, have already dramatically changed the way students, marketers, consultants do their job. And I'll give you one example. One of the key things that I did during my days at IBM, along with Ewan and several other people from my firm who subsequently joined to work with me, were create what are called target operating models. So they are an overall map of how the enterprise works together. Now, arguably, the biggest beneficiaries of a target operating model are not these large global corporations, because those things are already fairly well understood and they're well documented. Brand new startup, an emerging tech startup, would actually get a lot of mileage around a target operating model, but they couldn't afford them. They required a lot of brain work. Even a small company would require a team of 2 or 3 business analysts working for 4 to 6 months to create a credible target operating model. Generative AI has changed that. Now we did a target operating model for an early stage startup. I asked ChatGPT to make me a straw man of it, which was wrong in every respect, but allowed me to do the rest of the work in maybe 2 weeks. Single person for 2 weeks rather than 2 to 3 people for 4 to 6 months. So it has fundamentally changed and made it possible for early startups to get this kind of expertise. And a startup that has a target operating model allows its founders to do a far better job of prioritizing where to spend their time, because time is the most valuable resource in an early stage startup. If you're doing something, you're not doing something else. And if you actually understand all of the pieces of a business rather than the ones, that you as a founder have, as a founder, there might be 8 different things you need to do in a startup business. And a founder, you're probably really exceptionally good at 2 or 3 of them and might not even know that you have to do 2 of them. So there's going to be a wide variance in terms of what your capability is. If you can understand that up front and understand which of those things are important and when they are important, you're going to do a far better job as the leader of a startup. And now it's within the affordability envelope for most early companies. That's a fundamental thing that has changed literally in the last year and a half because of AI. So it's not just notional. What is notional in AI, to my mind, still is now the biggest hype, which is agentic AI. To my knowledge, there's no actual real world deployment of agentic AI. It's It's a great place for consultants to make a lot of money. It's a brilliant idea, but nobody is really doing it in a production kind of way. And I fully expect that some of your listeners are going to pop up and say, Areiel, you're wrong, which is great, which is fantastic. I'd love to see it. And it's entirely possible I am wrong. But I have not seen evidence that agentic AI has been used in a structured industry strength way yet.
Yeah, in general, I mean, what I'm seeing from just kind of scanning social media, and I'm in no way an AI expert, nor do I claim to be. I'm interested in it, and I've dabbled with a few kind of LLMs, agents, whatever you want to call them. And for me, it's like, yeah, consultants are making a lot of money setting them up and getting them going, but the results that are getting spat out the other end is something that's consistently people are saying it's just wrong. Like there's just it's still not automated or reliable enough to the point where we can let the agents run loose. And that's an overarching theme I'm kind of hearing on the agentic space.
Yeah, and if you pause for even a moment, you wouldn't expect it to be, which is fine. So when we did the 𝗵𝗂𝘁 project, it took 6 months and about 10,000 loans to train the model to the point where, eventually we got to a model that outperformed FICO by 26%. It actually reduced the non-performing loan ratio of the underwriting bank by 26%. Unlocked literally, peak loans origination per day because more people could qualify, went from 500 a day to 50,000. Okay. So results phenomenal, but only after running, and this is absolutely not analogous, but you would expect to need a training period of a minimum of 6 months to a year at a reasonable transaction volume before you could expect an agent to be good at its job.
Which is interesting because it's similar for a human being, right? They say it takes a year for a person to get into the role. So I think, like it's one of these balances where like, if you're not doing something, you're missing the opportunity or just delaying your ability to have a well-trained product when it's needed. Absolutely. I don't know.
And when you hold that up to sense check, that doesn't mean it shouldn't be done. And it doesn't mean that agentic AI is a bad idea. It's an awesome idea. It actually increases the value that humans can add, which is kind of counterintuitive. People tend to fear it as a job killer, but it is. What it does is it increases human productivity because now a human can stand aside an agent and get a lot, and have the ability to exercise human judgment over more. So now that's not to say that a lot of people won't use it purely as a cost-cutting measure and quality will suffer, but it doesn't have to be that way. And over time, it won't be because the companies that treat their customers better will succeed. It actually is a multiplier of human effectiveness at the end of the day. Now, having lived through the dot-com boom, the dot-com bust, and the huge social disruption caused by globalization, it's easy for me to blithely make a statement like that. The amount of human disruption should not, 2015, the number of people in the world living in extreme poverty, the lowest level of poverty as measured by the World Bank, fell by 70%. That's never happened. So we've arguably materially changed the lives of 2 billion people. And the mechanism is labor mobility. Studies shown again and again. There's actually only 2 ways to end poverty, at scale over time, apart from just, because, philanthropy doesn't scale. There's 2 ways to end poverty that actually work. One is educating women, and the other is labor mobility. If people can go to where there are jobs, there will be less poverty. The internet upended that. Now the jobs can go to the people. So that is a genuine reduction, saved the life. We literally changed the lives of 2 billion people in a positive way. We destroyed the lives of tens of millions of people to get that 2 billion in savings from all the people working in manufacturing jobs in Western economies who lost their jobs. Was that a good thing? Yeah, on a macro level, it was. I have no, I don't question that in the least. But you know what? We generated so much wealth as a result. We could have done so much better job taking care of those people whose lives we destroyed in the process. You'd say, well, we didn't know it. We didn't understand that. And that's true. There's no precedent. There was no history to lean back on and to predict what was going to happen. We know it now. So when we're busy out planning this next round of disruption around AI, it's easy for me to say this statement, okay, this enables human productivity. It makes humans more effective. And I do believe that. But that's not going to say it's not going to disrupt. So we need to be thinking about the social costs of what we're doing every step along the way, and making sure that we behave more responsibly, since now we're educated and we know what's going to happen.
What's the likelihood of humans actually, heeding that lesson and implementing it? Because again, the skeptic in me suggests that humans, even if you know the lesson, don't necessarily apply it.
Well, so it depends on how. Okay, so there was a set of operations research studies done in the late 50s and early 60s that shows two companies selling nearly identical products in a local market, identical in every meaningful characteristic, but one company, for a reason, enjoys a 1% cost advantage. It will put the other company out of business in 8 years with a 1% cost advantage. So, the lesson there is, it doesn't matter if you are socially responsible. If you can't manage that, if you can't deliver 1% better cost, the less responsible CEO is going to beat you as a competitor. And your ability to change the world in a positive way will be zero, because you'll be out of business. The mandate for an innovative leader is to find a way to use that transformation at a way that creates a cost advantage. Because if you have even a 1% cost disadvantage by trying to be the good guy, your best intentions will not help the world.
Yeah, time will take care of the rest. Yeah.
You have to be thinking about how your ability to, we're talking about disruption, how your ability to manage disruption delivers a cost advantage to you. Now, that shouldn't be impossible. And we'll come back to specifics. You're training AI agents. Those people, who would otherwise be targets for disruption, they have a lot of institutional knowledge. So it's not a zero-sum game, and it's not impossible to think of models where you are generating a genuine cost advantage by looking after people with that immense accumulated knowledge.
Do you think there's a risk, though, that in the phase when the agents get good enough to replace humans, and let's say humans don't learn the lesson of looking after the people that will be affected, there will be a generation or two that get left behind? They're the generation that they basically had, through their working lives, the agents that were doing the jobs that they should have been doing at the expense of their existing diminishing corporate knowledge and the fact that they never had the opportunity to learn it in the first place. And then we might learn the lesson, and then we might reintegrate them. And then that new cohort will be the privileged ones.
And it's worse than that, because that class of displaced people will be easy prey for politicians on both the left and the right.
Yeah,
to offer simple answers.
True.
And demonstrate the basic empathy for the disrupted.
Yeah. Alex, you had a question, sorry.
Yeah, so I mean, I'm going to play a bit of devil's advocate here,
Okay.
which is essentially advocating for kind of innate human greed and the potential for kind of AI feudalism to just absolutely disproportionately take control.
Well, I don't think that's devil's advocate. I'm saying that you're absent the action of innovators who try to derive a cost advantage out of being responsible. Your scenario is what will happen.
Yeah.
It is
the
the
arms race,
default.
isn't it?
So no, there's no devil's advocate. I agree with you. But look, you won't be able to regulate it, because all you'll do, that works on a macro level too. So let's say, okay, so we're not going to do that. We're not going to allow that here in the UK, because we're better than that. All you've done is handed over the competitive advantage to a country that doesn't have those scruples, whose people don't have those scruples, or whose leaders don't pay attention to the people and don't have the scruples. So just saying, well, we're going to be better than that, or we're going to regulate against it, or that doesn't solve it, because you've got that same competitive advantage just working at a national level instead of an enterprise level. So to my mind, necessity of delivering disruption at a cost advantage, delivering disruption in a way that looks after the disrupted with a cost advantage, that to my mind, that's a moral imperative. And what are the odds of being able to do better than this default scenario? Better than they are if we ignore it.
Yeah.
So how do you play that out then, like from a futurist point of view, and essentially what's going to be a global arms race? What's the ramifications of that?
Well, in terms of regulatory policy, you need to be friendly to innovation. You need to find a way to boost the competitive advantage in a place where you're motivated to behave responsibly. So rather than, I'll use an example, and this is probably going to get me into trouble, but that's fine. It wouldn't be the first time. And I'll do it because it's something that's easy to understand.
Okay, no, Alex, this is going to be a snippet for the podcast. This is the
and I'm using this as a thought exercise. I'm not actually advocating this, but let's look at fracking. It is a technology for extracting coal that there is some science that says it has potential long-term effects that are not well understood and potentially damaging to the environment. So one way to solve this is to say, well, fracking's illegal here. So what's going to happen? Okay, there'll be no fracking in the U.S. There'll be no fracking in country X. Does that mean fracking won't get used in, say, Venezuela? I guarantee all you're doing is you're handing that advantage to Venezuela, and the fracking technology and the investment in developing the tools, the infrastructure, the process models, the operating models to support fracking will continue, but they will continue in a place with far less scruples. Or you could say, fracking welcome here. Here's a set of environmental metrics. Here's some tax credits. Develop it here, and we're going to overcome the cost disadvantage out of fiscal policy so that it makes sense. And the dominant fracking tech is going to be as responsible as it can be, rather than developed in a country like Venezuela, which will then become the reference tech for fracking without that influence.
But then building on your responsible behavior model, in theory, what should happen then is the company that sets the standard shares the knowledge and experience in technology with Venezuela so they don't make the same mistakes, which is only going to increase the speed at which their competition rises. But in reality, you want them to make those mistakes so that they remain less competitive.
If you subsidize the development of the tech, then the greed motivator will take care of the rest, because I've got this tech and it's now working and approved for use in the US. Why wouldn't I want to sell it to every other market in the world?
Yeah.
So, and I am not an expert on fracking. I know nothing about it. So, like I said, I am not advocating it.
Blockchain's another example where it's like people fear it, they don't understand it. It's a competitor to the current system as we know it. Do we banish it or do we own it? Like, you see countries kind of yo-yo in between those two stances in terms of crypto and blockchain.
Well, so blockchain is actually a really, really interesting case study for a number of reasons. The basic idea is incredibly old. It's older. It's about 12,000 years old. It's older than writing. If you go to the British Museum, you can find this thing called a bulla. It's a clay ball, and they were made in ancient Sumeria starting about 12,000 years ago, and they are the earliest form of contract that we know of. So basically, you and I are farmers in Mesopotamia, and you lend me your cattle to plow my fields because my cattle got killed by bandits or stolen or what have you. And this developed about 12,000 because that's when we were moving from hunter-gatherer to an agrarian business model, if you want to call it that. And that created what I call the world's first business requirement, which is an independently verifiable record of an agreement, of a future commitment between people. The future, when you were nomadic, future didn't mean anything. You had no idea where you're going to be in 3 months, let alone next year. But the moment you start having a regular agrarian cycle, it's possible to think about what happens next year. But you need a way of building trust. So the innovators of that time created a new technology, just exactly the same way we do it now. So you and I have this deal where, you're going to lend me your cattle now, and I am going to give you 10 bushels of grain at harvest time. Now, come harvest time, maybe you say, actually, no, you told me 12. No, I said 10. And let's assume for this that we're both, it's a genuine misremembering. We're not, nobody's trying to, to steal here. So what this thing called the bulla did is when you made the contract, you bake this clay ball, and into it you put pebbles. And at harvest time, and you fired the ball in a kiln. Harvest time, you break it open, and there are the pebbles. The world's this is 4,000 years before writing was invented. The world's very first contracts were tokenized. This is not a new idea.
So my question is, how did they know which balls were, how did you mark the ball to make sure you were both kind of tracking the same one? And who kept custody of the balls?
The creditor.
Okay, yeah. So these are, I guess, like, again, you kind of early version of a bank, right?
Yeah.
Yeah,
Yes,
or lawyers, or this is, you can see how different,
So, and over time, what happened, you started inscribing on the outside to make sure that the ball is recognizable, et cetera. So these things grew and grew in complexity. But what was really interesting, if you look at the archaeological record, is the moment these contracts came out, the average size of a farm started growing. So before this, a farm was, the thought model of a farm was a subsistence thing. It's big enough, it's field big enough to support your family with the technology at the time, which is this very, very primitive plow called the stock plow and 2 oxen. All the farms were, but the moment you had this contract, you see the size of the farm started growing. And you think, somebody said, if I can do this for one, why can't I get 20 cattle? Now I can farm, So this, tokenization in its earliest incarnation allowed people to stop thinking of farming as a subsistence activity and start thinking for the very first time, as far as we know, as an enterprise. So tokenization has been unlocked this enterprise type mindset 12,000 years ago. This is not new thinking. We found a way to use modern technology to make it much more scalable, but it's not a new idea. So blockchain is interesting because the core idea has been around a long time. But the other thing that's really interesting about it is that the challenge is actually not one of technology, but one of standardization. And I'll explain what I mean. So if you are an enterprise architect at a bank, at an insurance company, at a logistics firm, your job, one of the main parts of your job, is to make sure that the applications that you run your business on are safe to use. What you don't do is say, looks good to me, and you don't do that for a few reasons. One is because you're assuming unlimited risk. Okay. If you say, I've looked at it and I think it's safe to use, anything goes wrong, it's your fault. The other reason is, it doesn't matter how good you are. And I'm assuming for all of this that you're actually capable and diligent and all this. That is not, the statement that, Alex says it's good doesn't mean anything to my board, to my investors, to my customers. Okay. So what an architect does is he expresses his opinion in the form of saying it complies with these standards, which actually gives a frame of reference to anyone who's going to care about architectural approval in the first place. So think about, this is 2016. You've got a blockchain for originating letters of credit. Well, inside a bank, one of the main standards is data never leaves the firewall. You go to a bank, you can't connect to their Wi-Fi. You can't even bring a USB stick in the door, as it should be. No problem with this. When we did this project, we built the solution in 15 weeks, finished on time, under budget. It took 1.5 years for them, and I'm not talking about regulators, to get internal approval to even pilot this. And the problem wasn't that the architects at the banks didn't think our solution wasn't secure. They thought it was more secure than what they had now. But as an architect, how do you approve a solution for use with the standard is data never leaves the firewall? A blockchain, by definition, is going to take my book of business and federate it into the data centers of every single one of my competitors. That's about as flagrant a violation of the existing standard. So coming up with a basis on which you can approve this, even if you think it's more secure, is not an easy thing. And it's what makes blockchain such a fascinating case study. How do you, because it's not just about the tech, but it's finding a basis to approve the tech for use.
Yeah.
In a lot of ways, we still haven't done that.
Yeah. I mean, my experience in the finance systems world is, you've got like a player like Swift that is enabling connections between financial services institutions around the world, and its security is super high, and it's very difficult to become part of the Swift network for all the reasons you've just described. Data sharing, transaction information, lots of sensitive information, time sensitive, high value, high risk. And yeah, I wonder, like, you're building a system there for an internal bank. How easy is it then to create something like a Swift, which is trying to connect and share data between these in these kind of like siloed organizations that are quite protective and maybe not
Well,
as
it's
flexible?
the people side of that is far harder than, creating the tech is an interesting challenge. It's hard, it's expensive, but ultimately doable. Moving a group of stakeholders, considerably less so. I mean, Swift itself is not blind to this. They were one of the 40 initial sponsors of 𝗃_𝗀, which was, a very, very interesting, or is a very interesting DLT technology. It's not a blockchain because data is not federated across all nodes. It's only federated across nodes that are relevant to the transaction, which you'd expect given what it's trying. 𝗃_𝗀 was very much an answer to that problem of, well, we'll have the DLT infrastructure, but we're only going to federate it to the relevant nodes. And that's, that was a way to get, that was specifically to address this problem of data federation and architectural approval. So, and Swift, you would think that they would be, amongst the most fearful, but they weren't. They stepped up. They said, we're going to sponsor this because, we know this needs to happen. Swift are not blind to this. I mean, they've got a bunch of very smart people there. And the other side is because, it also affected the architectural choices that I made in the project that I did, because, using a blockchain solution, we didn't need a lot of the data overhead, but we still based our on-chain records on the Swift message.
Yeah.
There were 70% of the fields we did not use. But
talking about your standardization, I think Swift is also credible because it uses ISO standards, right? It comes back to your point about
that's the point. Even though 70% of of the schema we didn't use, the fact that we said, "Oh yeah, we're doing Swift 707 messages," it made the conversation a lot easier. It also
social
made
validation and trust.
Well, and it made the integration easier because people already had systems that could pick up Swift 707 messages. So it just, at the cost of an inefficient schema, bought us a lot of adoption.
Yeah. Okay, so I think we've covered blockchain. Sorry, before we move on, like, one thing I'd love to chat about offline, not on the podcast, is an idea I've had for basically a new Swift system, and you'd be the man to talk to on that. Okay. So I guess we've covered kind of where we are on AI and a summary of that, blockchain quite nicely. The next piece, would you mind just giving a kind of quantum for dummies? Where are we? Where are we now? What are the key constraints? What are the positives? What are the potentials? Like all the stuff you've done for the other two.
Sure. So quantum computing, the idea behind it is that a quantum algorithm, or quantum mathematics, can solve simultaneously what regular computers have to solve serially. And they do that by the fact that the basic unit of computation is this thing called a qubit, which is basically a quantum bit. Classical bit has a value of 1 or 0. A qubit can be 1 or 0 or both, which means that as you add qubits, the computing power compared to classical bits exponentiates, because for every bit you can have 1, 0, or both instead of just 1 or 0. So by the time, that exponentiation is very fast. Will give you, expressed in classical bits, would give you one bit for more than one bit for every atom in the universe. It's mind-blowing scale. So if you think about solving things like protein folding, weather climate modeling, all of these things where you have immense, so imagine if you can model every atom in the universe, it becomes a lot easier to predict the weather, right? But here's the thing: creating qubits is hard. They don't exist in normal space time. You have to create some pretty weird and extreme conditions to instantiate a qubit. You could try to do it with superconductors in a very cold environment. People try to do it in a vacuum with ions. They've tried using photons and lasers. They're trying, they looked at topology, weird topology of nanoparticles. So there's a lot of, but all of them are expensive and involve extreme environments. The other thing, as hard as it is to create a qubit, measuring them is even harder. And that's because, so this state of 1 or 0 is, it's a hard idea to get your head around, and it's hard even for scientists. And there was a famous letter that was written in 1930 from Schrödinger to Einstein. And Schrödinger was trying to understand what Einstein was saying. And he came up with a thought exercise that's now well known, which is, I put my cat in a box, and in the box, there's a device that has a 50% likelihood of killing the cat. Until I open the box, I don't know if the cat is, the cat could be alive or it could be dead. And Schrödinger wrote this to Einstein saying, do I understand it? And Einstein said, yes. And then, that is now called Schrödinger's cat. But the point is, and that quality is called superposition. It's the term that quantum scientists and quantum computing people use. The moment you open the box, that superposition goes away. It's either alive or dead. You no longer have that exponentiation of power. So you could say to a quantum computer, solve Shor's algorithm, do this, do that, do the other thing. But the moment, and the quantum, will run its algorithm and say, okay, I've got an answer. Great, well, show me the answer. Well, the moment I try to show you the answer, I've opened the box. And I know, so you can't actually directly copy the correct answer. There's no way to.
Interesting. Is that linked in any way, shape, or form to the observer theory?
Well, quantum entanglement is one of the ways you try to get around that. Okay,
Right.
you can't open the box, but if you've got an entangled bit that's doing the same thing, maybe you can look at that. I don't want to get too deep into the weeds.
Yeah. No, sure. Yeah.
That is one of several ideas. The net is that, so we say 300 qubits is enough to model every atom in the universe. We've got, Condor, IBM, that claims it has 1,100 qubits. So why hasn't people, why are we still only at n = 21 for Shor's algorithm on quantum computing? Interesting. I'm doing some work with a company called Dynex that actually can do, emulating quantum computing on classical framework, can do significantly outperform that. I actually just put out a white paper this week on that.
Yeah, we looked at it. We looked at it as part of, we scanned it as part of the prep for this, but no, it's essentially a quantum simulator, right? In a simple term.
Getting back to the course. So the idea, the problem, so you've got this computer that claims to be running 1,100 qubits. Because they are so hard to measure, they are so hard to keep stable, there's so much noise, there are so many problems. And measuring a qubit, these things, you can't see them with an electron microscope. So even if you had a technique, so there's difficulty upon difficulty upon difficulty. So right now, the ratio of logical qubits to physical qubits is in the hundreds or the thousands. So even though theoretically we've got this 1,100 qubit quantum computer, it's having trouble, doing things at 8 logical qubits. Quantum annealing, because it's more focused, a little bit better, but still nothing like what you would need to solve real world problems. So that's the first. So we're at the very, very infant stages in terms of the quantum power that is available to us. Further along, so like with Dynex, much further along in terms of emulating it, but in many cases still far short of what classical computing can do. There's a few use cases where the Dynex simulation actually could deliver real world value now, which is actually pretty exciting. But in most cases, classical computing is still far ahead. So that's one thing. Quantum is very much in its nascency. The other thing is that, to my mind, that will get fixed. People will get better. They will improve the ratio of effective physical to logical qubit, and they'll create machines that have more qubits. So this will eventually get solved. The bigger problem, to my mind, is learning how to develop quantum software.
Yeah.
I started trying to teach myself. These are the most Teflon-coated ideas I have come across in my lifetime. For me to sit down and understand, I'd like to think I'm reasonably intelligent. I do have a degree in econometrics, so I understand probabilistic math and stochastic calculus relatively well. For me to sit down and try to understand quantum mechanics or a detailed quantum algorithm, I can barely almost do it, and I'm not exaggerating here. If I am sitting in a dark room, no music, no other, the moment I get even the tiniest bit of utter stimulus, it's gone. It is at the very, very edge of my cognitive ability to understand this stuff. So this is not something that you can just, now we're teaching every high school kid comes out knowing how to program a Python. This ain't that. So we're going to have to find a way to distribute the expertise of quantum programming. It's not impossible. You do not need to know the IP stack to write a mobile app, but that is a big, big step that we're going to have to understand the different rules and design patterns for quantum software development in order to get to a point where we can start delivering quantum software at a scale that it needs to be able to affect the world, which gets us to my mind, one of the first big interactions, coming back to your question that you actually asked, which is quantum and AI. Okay. And this is one of the big places. I don't think humans will write quantum software. I think humans will train AI.
I've just noted that as a question. Yeah.
And AI is being used now. And the other things going back the other way, which is AI is being used now to do a better job of building quantum computers. So these things of making quantum computing less noisy, better coherence rates. Okay, we're harnessing AI now to improve our ability to create scalable quantum computers. So there's a two-way cross-pollination between quantum and AI. One is to do a better job, help to do a better job of writing software, and to do a better job of actually developing quantum computers.
You mentioned the 300 qubits being analogous to like every atom in the universe is worth. So I mean, from a deterministic point of view, you could kind of create an oracle in some futuristic world. I don't know how that would
Well,
work.
yeah, you get into a huge theoretical tangle. Bringing in another name besides Schrödinger, which is Heisenberg. You can't measure something without changing it. You could, it's conceivable to say, okay, so I can have a state model, the one bit for some binary attribute of every single atom in the universe. That's great. Now, how do I create a sensor that measures that? So, I mean, it's like, this stuff is mind-boggling beyond belief. It is not inconceivable to have a whole universe model. Right now, I can't even measure light across the universe. The 14 billion
What
years
if?
old.
So you mentioned that you did kind of a self-optimizing linear regression model. So, or not linear, but regression model. So is it maybe, do you reach a point where it's easier to just self-optimize empirically than to measure and try and fine-tune, if that makes sense? So just generate so many permutations and be like, which one's the
Well, I
closest to
mean,
right
and
now?
that's in essence what you're doing. I mean, the whole idea behind quantum is that it can solve things simultaneously. This is why, and this is actually something that Dynex did really well. This is the classical traveling salesman problem. The reason a quantum computer can solve it, theoretically anyway, is that it can look at all it can look at all the permutations and say which one.
Sorry, what is this traveling salesman
So
problem?
the traveling salesman problem it's one of the first historically NP hard problems that we know has been defined. It's been around since the 1830s. So it's not new. And it is a reference case for quantum computing and indeed for a computational science in general. The idea is that you are a traveling salesman and and this was 1830s. So it is salesman, and you have N cities, a number of cities you have to visit. You have to visit one each on your tour to show off your new product. What is the path between those cities that is the shortest, that takes the least amount of time? So if you think about the business implications, logistics being the obvious one, but it's not. It's networking. It's the path of a data packet. It has to do with with telemetry. And so many applications of TSP, traveling sales problem, in the real world. But the number of different permutations exponentiates rapidly with each node that you try to answer.
Hey, Alex, this reminds me of that slime you pitched as one of your favorite innovations. There's a slime in nature that connects multiple nodes and finds the most efficient path. And we explored a case study where that slime could be used to solve things like how do you redesign cities and how do you redesign road networks. And yeah, it'd be interesting to see if nature has already invented a solution to this. But anyway, sorry.
But anyway, so like I said, so it is a classic problem in computational science and one of the reference cases for quantum computing.
Okay, so right, so in terms of my head, right, I'm just going to summarize where we are right now. Quantum is hugely powerful but unstable, but time will chip away at that and improve it. We've got AI that's also improving, and if quantum coding isn't something that humans will need to do because AI will do it for us, and quantum improvements will also largely be managed by AI, where are we in terms of what's the next step in the kind of
Well, so,
prediction?
yeah, I think that because quantum mechanics is so hard for humans to understand, or even forget the mechanics, just quantum gate logic is so hard for humans to understand. AI is going to be the only way to deliver quantum software development at scale because there just won't be enough humans who can get their brains around this. I shouldn't be that pessimistic. It's entirely conceivable that people could come up with educational techniques that are much better than the ones we have now. I mean, there's all sorts of case studies of being able to teach calculus to kids who are 6 years old. So maybe it is possible.
Is it not a similar case of imagining the old ancient Greeks, all the intellectual greats that we refer back to in history, not being able to imagine our level of technical ability now in terms of being able to code languages that we consider normal? Surely there's a degree of just normalization and just the new coding languages will be the standard. Like, yeah, maybe that's again like being, if humans even need to be there or if they add value at all would be the,
Well, no, I mean, and there's definitely an element of that. I cannot help but being skeptical that will cover quantum mechanics, though it is certainly true of AI. I first saw this phenomenon in the 1990s when the world moved from procedural to object-oriented programming. I played a part of that. And this is actually one of my last jobs as a coder was in 1999, and my client was the U.S. Federal Reserve Bank. And I was the lead architect for a project that moved the system that calculates the daily capital reserve requirement for banks from Fortran, procedural language, to J2EE, which is Java, enterprise Java. Um, so, and one of the things that I was noticing when I was doing that project is that the younger developers who started their career learning object-oriented were much more productive than developers you would have expected because of their expertise and their industry experience to be better. And it wasn't making that cognitive leap from procedural to object-oriented not that difficult. I mean, the basic idea made sense, but the object-oriented natives were able to innovate with new design patterns better than the people who had to retool the way they think.
yes.
We see this now with AI. The younger AI programmers, the younger AI data scientists, quite frankly, are better than
Yeah.
older, more experienced
Yeah.
data scientists.
It's a humanism, right? It's
Yeah.
something that we
Yeah,
can't
so
really avoid.
the AI natives are going to be better at this than the people who had to retool their minds.
Well, there we are, Alex. Good. You'll be leading the charge because I feel like
Yeah,
I'm too gone already. I'm not going to be able to keep up.
and I have to assume that will be true of the quantum natives as well. But we're talking about a huge intellectual gate that doesn't exist with AI, that doesn't exist with blockchain, that didn't exist with object-oriented programming. So it's a higher bar. It's a much higher.
Yeah. Okay.
I'm going to jump in with a straight kind of holistic question here as a proud
Mhm.
hodler of the Bitcoin ecosystem. What is the future for that look like? Because I feel like the number one black swan event right now is if someone somehow figures out how to beat 𝗪𝗂256 in the backyard, like what does that mean for the whole crypto industry?
Well, it's not, I mean,
Sorry,
no,
can I pad that out actually because it links to my next question. If we talk about quantum built systems in general, it's not just blockchain technology that's at risk. Every existing system, and we talk about an arms race of a country, winning that first, from a security existing systems point of view, it almost is a blank canvas approach, right?
Yeah.
How do you integrate and iterate existing
Well,
systems? Like at what point do you just cut and
Yeah.
start again?
Yeah, again, just bringing it back to business now, this is actually the area where my firm has actual commercial business in the quantum space, which is helping companies achieve quantum resilience. So this is a service offering we have now. We have clients who are doing it. So this is something that, because you don't need quantum computing to make your software quantum resilient.
Interesting. Okay. That's good to know.
So we're helping companies plan for quantum resilience now. So I could probably spend 2 hours just talking about this topic because it's something that we're doing. I'll try to to shrink it down. 16, NIST, which is the U.S. federal government standards body. So the U.S. doesn't like to regulate unless it absolutely has to. What it'll do is it'll issue a standard and say, if you want to do business with the government, you have to implement this standard. And it becomes kind of a de facto regulation without having to actually wield a stick, which is more the EU's preferred way of doing it. But anyway, so NIST started a competition in 2016 for quantum resilience. So, and, it's all open source, so everybody could see the algorithms. If you went through a series of evaluations that NIST sponsored and you got to the point where NIST would certify that your algorithm is quantum resilient, the prize, if you will, was the opportunity to put your algorithm forward for, the U.S. government's mandate that it wants to be quantum resilient by 2030. So they started this competition in 2016. In 2022, they announced the first 4 winners. So there are 4 algorithms out now. You can just go download them. They're open source, that are certified by the U.S. government as quantum resilient.
I mean, to play devil's advocate slightly here, surely the defense of a system is only really tested once malicious actors have full access to it. And because the barrier to quantum is so high, how have they been able to simulate that level of malicious attack? In the same way that like crypto and blockchain
Well,
has had
and
a bunch of people try it and succeed in
I
cases.
think that, while your statement is true, the caliber of people who've been working on this NIST, the level of certainty is quite literally as good as possibly get. That doesn't invalidate what you said.
But is there a risk of the caliber of the people who can understand this and play with the tools is essentially an echo chamber of knowledge where they're almost marking their own homework, and it's really hard to like I found when I've worked in systems,
but it's a
the thing
competition.
that tricks you up isn't the thing that was on your
No.
list of things that you test.
You're grading to a curve and marking your competition's homework.
Okay.
That's
So
it's a little bit
just
different
to
model.
jump in, can you kind of try and dumb it down to normal people language of
Well,
what is it?
I'm getting there. So
Go for it. Go for it.
we've got these algorithms that are certified as quantum resilient, and then we've got things like AES 4048, which people posit even before NIST are already quantum resilient. So we have some ways to do this. So we've got these, we actually have things we can implement now to make systems quantum resilient. So now let's say, so if you are a mid or large size company, you are running anywhere between, say, 500 and 20,000 different pieces of software in your enterprise. Some of those, so you've got this portfolio, you're the CIO, and you have to keep, your job is to make sure that this is quantum resilient before Q Day, which no one knows when it's going to be. Earliest I've heard is, from credible people is 3 years. Jensen Huang, NVIDIA says 15 years. Nobody knows. But your job, as CIO is to be quantum resilient before Q Day, whenever that happens to be. You don't know what it is, but you do know, and we saw this with Gen AI, when it comes, it's going to come. I work to a 4 to 6 year planning cycle myself, not because I think I have a better answer, but because that's the average length of a CIO's planning cycle. So if I plan to replace things for quantum resilience, and I inform that I can achieve quantum resilience with minimal marginal cost, because that's my replacement cycle anyway. So the average CIO is sitting on top of a portfolio with 500 to 20,000 different software applications, and I've got to make sure every one of them is quantum resilient because any one of them is a vector for attack. Some of them. Okay, and we've actually built a CMMI type maturity model that my company uses. It's it's part of the IP that we bring to doing this resilience planning work. Some software is already quantum resilient now. Great example, Zoom. They made the switch over last year. So if you're conferencing on Zoom, you already have a quantum resilient conferencing platform. Huzzah!
Hey, that's what we use.
So that's what I call tier 4. Tier 3 is, it's not quantum resilient now, but it's in the roadmap. Microsoft Office supposed to be quantum resilient by 2027. So what do I have to do as a CEO? I have to monitor. I have to make sure that Microsoft, goes ahead and meets that commitment. I also have to apply the upgrade when it comes. But it's not a huge amount of work. It's just something I need to stay aware of. That's tier 3. Tier 2 is where the software isn't quantum resilient. It's not on the roadmap, but the software has a pluggable architecture where if they won't make it quantum resilient, I can, because I can basically swap out the encryption algorithm to something that is. Good example of that, SQL Server. So SQL Server has pluggable encryption. Now that's not as good as tier 3 or 4 because now I have to do it, which means I'm taking the risk. I've got the cost of ownership, and it's a project. I have to pay people to do it, but at least it's achievable. But then you have tier 1 and tier 0, which tier 1 is there is no path to quantum resilience. The architecture does not allow me as the owner operator to make it quantum resilient myself. Tier 0 is the platform is already out of life. The platform isn't even supported now, let alone quantum resilience. So we have not done a scientific study of this, but anecdotally, clients we've talked to, our belief is that in your average software portfolio, you're looking at 20 to 30% of your software applications that are in tiers 0 and 1.
Wow.
Okay.
Where do you think somewhere, like coming back to the Swift example, I mean, feel free to not answer this, but like where are banking systems in Swift and kind of vulnerable networks like that?
Well, yeah, and I don't think you can paint with that broad a brush, and I'll explain why. So, Swift itself, it will do that. Microsoft, SAP, Xero, any company with reasonable critical mass will probably do what it takes to achieve quantum resilience. But so the 20 to 30%, a lot of that, I mean, some of it will be just small companies without the critical mass, but a lot of it will be homegrown apps. Many companies, and I definitely include financial services companies in this, some of their mission critical apps are homegrown. The developers, they've been using this app for 20 years. The developers are long gone. The code's not documented. Okay, so they're sitting on something that is a problem now. And there's absolutely no path to quantum resilience and never will be because they don't, it's not even in support now.
Okay, and then take away. Sorry to interrupt. There's another layer here that is AI related in the sense that all these no code, low code, vibe coding projects that we're anticipating sweeping the market soon, presumably are also extremely tier 0 products that we're going to be flooded with soon.
That presumably will shake itself out as that market matures.
Yeah.
If you're still running one of those when Q-Day hits, you're in a world of hurt. But the market as a whole will I think move and embrace. I think a significant portion, if not a majority, of the tier 0, tier 1 apps are going to be homegrown apps. They often are in mission critical positions. But coming back, and this is why I'm using a 4 to 6 year planning cycle. If I know that now, great. I tell the board, here's my software retirement plan for the next 5 years. The board's going to give me a certain amount of money for IT transformation anyway. This just informs how I prioritize. So it should be possible for many companies, if they do the planning now, to achieve quantum resilience as a matter of course. This is why we are selling quantum resilience planning now. And we think that despite the fact that the quantum tech itself is not mature, this is the right time to do the planning. Because if you take the planning now, you can achieve quantum resilience without a huge outlay of additional cost.
At the very least, it should be a factor in a systems procurement review, or factoring in when a license renewals update.
Absolutely.
Yeah, interesting.
So does that answer? I mean, that's a rather long-winded answer.
Yeah, no, okay. Right, so let's start moving on to the crux then. So we've got, where does blockchain fit into this? Because again, and things that I'm picking up on, I see a lot of stuff about Web3 and, everything that you do online being on chain, and whether that's, digital receipts, like everything that you own is on chain via NFTs, whatever you want to call it. All of your activity and all your data is on chain and owned by you on Web3. I still can't quite compute how Web3 integrates with real life, but I'm sure that will make sense soon. And then,
You're not alone there.
like, where does blockchain fit into this? Assuming that, not just cryptocurrencies, but blockchain technology might underpin things like smart contracts, ownership, your own data being held in centralized wallets, which with zero proof knowledge and concepts like this, which are no brainers. Yeah. How does blockchain integrate into what we've just described so far in terms of AI plus quantum systems?
Okay, so let me talk about blockchain and AI, and then we could talk about blockchain and quantum.
Okay.
We've
Nice.
already talked a little bit about AI, so let's look at it at the bilaterals. So blockchain and AI, obviously, is something that people are doing now because both technologies are being used in the real world. One of the biggest areas where blockchain can help invigorate AI is in data provenance. Okay, so AI right now is kind of the Wild West. You've got that fabulous disaster at Samsung. You know the Samsung story with ChatGPT? This happened, I think, about a year and a half ago now.
Which just recap it, and might spark a bell.
Some geniuses at Samsung were faced with the problem. So Samsung has or had a highly proprietary mobile search algorithm for doing internet searches from any Samsung Android phone. And this is a deep trade secret, and they significantly outperformed anyone else. They had an internal problem, which is the unit test coverage was about 70%. So some genius decided, I'm going to ask ChatGPT to help. And I'm going to show them the code and have ChatGPT help. And it did. It brought it up to, I think it was 92%, something like that. So great result. That their highly proprietary mobile search algorithm is now public domain. It's not really, but it's part of the terms of service. One very junior employee in Samsung gave away the store. So data provenance in AI is a big thing, and an even bigger risk. And you haven't seen this much now, but again, this is something we've worked with a couple law firms on this one. That risk potentially is even greater the other way around. So let's suppose I'm an innovator at a small software company, and I've got a product, software product of some kind, and God help me, Apple decides to enter my market. Now I'm competing with Apple for my product. So how am I going to compete? So I go into ChatGPT and I say, please tell me Apple's digital marketing strategy for 2025. And ChatGPT gives it back to me. Now, let's suppose that what ChatGPT gave me is there because somebody at Apple did what they did at Samsung. And that for whatever reason, ChatGPT actually had Apple's digital marketing strategy. Okay. Now I'm using it to compete with Apple. Apple will sue me for using their, something that is proprietary and confidential, and they'll win. I had no idea. Okay. So so it's not just accidentally sharing, but it's actually accidentally using data that you are not authorized to use. So, and that is a risk that, that hasn't blown up yet, but it will, and probably not soon. Now, it's actually a risk that's very easy to mitigate. And again, this is something that we do with our clients. Suppose I ask ChatGPT a slightly different question. It says, can you please help me form a digital marketing strategy that helps me compete with Apple? ChatGPT gives me the same answer. I'm in the clear. I haven't asked Apple to do anything improper, or ChatGPT to do anything improper. So the lesson there is train your people on how to prompt in a legally protected way. And the other thing, log all your sessions so that when Apple comes at me, said, look, here's what I asked, here's what I got. And Apple can't. So this sort of framework is absolutely critical in terms of how you train. It also has to be critical in AI design, in your agent design. You have to put these limitations in your agent modeling as well. Coming back to your question, what blockchain can do, and I'm working on this now with with a client of mine. What blockchain can do is it can provide data provenance. Okay, so I can basically have on Ledger where I'm getting my data. What are my sources? It's immutable, it's secure, I can prove it. I've got the audit trail. And the thing about blockchain is that it is natively can handle a network of owners. And this has largely gone away, but one of the first questions that I ask people when they come to me and say, I'd like to use blockchain to develop this solution is, is it the situation, are you trying to solve something where there's only one owner of data, because blockchain is wasted. Blockchain, what it does is it allows, networks of different entities to use co-owned data. A classic counter pattern here in the UK is Tesco. So we did this work out in Indonesia with sustainably grown seaweed, which is grown in hundreds of small farms throughout the country with no common ownership. And it made a lot of sense because the individual nodes can provide contract security. There's a whole raft of benefits to farmers who normally get exploited. If you try to do that in the UK or throughout Europe, you'd be wasting your money, because Tesco basically is the de facto regulator, and it doesn't need distributed data. Tesco can mandate that the data is centralized. It does not need to solve blockchain to solve its data provenance problem. Tesco has become the de facto food safety regulator for Europe. You're running a chicken farm in Poland, and you have a salmonella outbreak. The Polish government comes out, finds out, they will fine you $30,000. Tesco finds out you're out of business. You're done. Okay, so Tesco is the de facto regulator of food safety. They don't need blockchain, because they can say, give me all the data, and they have the market power for that demand to stick.
But surely it would help them. Surely blockchain would allow them to remove the friction of needing to ask for the data in the first place.
Friction has zero cost to them. They impose that friction on their suppliers.
Okay. But cost aside, then time, just being able to monitor it and find opportunities to maintain their own standard.
I'm not aware of a use case in which blockchain saves processing, compute, or performance time.
Okay. So just okay, fine.
So
Well, actually, so I mean, Dan, this is one of your points. It's tokenization of securities. Surely that is more efficient and easier than how we're currently doing it.
Which comes back around where blockchain can play a huge role is in provenance of data that is not centralized, in markets that aren't centralized, in use cases and solutions that aren't centralized. Logistics, last mile logistics in most parts of the world is, if I send something to somebody in Africa or in some parts of South America, it'll get to them when somebody has a cousin whose truck is driving out. That's part of the logistic network. Now, Sanyao in China has done an awesome job of providing a technology infrastructure that handles that sort of informal logistics network and takes it as a matter of course. But if you want to do AI about around that, you have this huge map of individual data owners, and if you'd like to do it in a self-sovereign way, blockchain can provide that bridge of data provenance across a wide variety. So that is, to my mind, one of the huge areas of collaboration for AI and blockchain. So now we bring quantum into it. Okay, we want to do quantum key distribution. Blockchain's a great way to do it, to make sure that if I'm distributing a quantum key, the right owner of that key gets the key, only they get the key, and there's a record that I shared the key on this date at this time. It's immutable, it's auditable, all the benefits of blockchain tech. So that's a natural progression. Blockchain, AI to quantum. So that, that to mine is when you asked the question of me, it was 2-3 weeks ago now. That was the first use case that came up where all three would play a role.
Yeah.
In key distribution and data provenance.
Okay. So kind of dumbing this down then to Alex and I's level, assuming your timelines, let's say it is 15 years, like the number of years is irrelevant. Let's assume that the limiting factor here really is when quantum becomes mainstream. Let's say 15 years for all intents and purposes. What does it look like to be a human being? And what is it like to exist as a human being when there's this amount of computational power, information sharing, real-time data, secure data? Systems might not be as dramatic, given that we can protect, and we can, assuming we've got tier 3, tier 2 systems, or everything tier 3 and tier 4, quantum resilient. Assuming in the 15 years every system we use is quantum resilient, and therefore the old systems can live alongside the new systems. What is it like to be a human being in that world? And I don't, maybe maybe we delve into the whole brain-computer interfaces thing and us being connected into this world without even having control over that. Like, what does it look like to be a human being in this new world?
Well, let me start with the things that I think won't change. I think there will always be jobs, for one thing. That's not to say they'll be the same jobs, and it's not to say that people won't get hurt. We now know that they will, but there will always be jobs. The jobs will be different. And again, you want to look for answers to the future, look to the past. Think about the job of accountancy. And double entry accounting was invented in 1300s in general. Actually, we now think it was invented independently in Korea in the 1100s, but that died out when the Chinese invaded. The technology was lost. It was reinvented independently as far as we know, though there may have been a connection in Italy in the 1300s. And the corporation as we know it, say 1600s. So people have been using this technology to keep ledgers, and accountants have had the job of keeping ledgers from the 1600s until the mid 1950s. So in 1955, the first digital ledger came into being. It was a payroll system for General Electric in White Plains, New York. It was the first computerized ledger. It came out, and everybody, the degree of sameness is breathtaking. Everybody was saying, "This is the end of accountancy. This will kill the job of accountants." There are, there are more accountants now than ever. Okay, so the job of accountancy hasn't gone away. What accountants do, completely different. Accountants do not enter entries in ledger or check entries in ledger. They make sure that the systems are doing their job. But after an audit, an accountant signs an opinion, says, "It is my opinion that these financial statements fairly and accurately represent the financial position of the company that I audited." That opinion, ultimately, your job is to underwrite the risk. You're saying you are accepting accountability that those statements are correct. Okay. And that accountability is real. If you think about the Enron scandal, 2002, the world's largest accountancy, Arthur Andersen, went out of business because their application was faulty, or their opinion was flawed. Okay. So that is, the accountability is real. It's no joke. It killed the largest accountancy in the world getting that opinion wrong. So how an accountant arrives at that opinion has completely changed. But at the end of the day, the accountant's job is to accept that accountability. Medical, AI will improve. If you are the best doctor in the world, there's still no way you can stay on top of medical research. So AI can improve the performance of even the best doctors on the planet. But at the end of the day, the doctor is the one with the accountability. The doctor is the one signing the diagnosis. The doctor is the one who gets sued for malpractice if the diagnosis is flagrantly incorrect. And there was lawsuits. So, and again, moving AI. This is actually this is not even Gen AI, but there was a case in Lufthansa in 2009. Two people ended up sitting on a plane together and started talking. Realized one of them paid 50 euros for a ticket. The other person paid 500 euros for the same ticket. They took Lufthansa to court, said you're pricing unfairly. And Lufthansa was saying, well, we didn't look at your last name, your culture. We didn't apply any protected factors of bias. And Lufthansa lost and says, the fact that you did this with an algorithm doesn't absolve you of accountability to price fairly. Okay, so there's a clear role that humans will always have as agents of accountability. Type of work will change in ways that we, or at least I, couldn't begin to predict in a post-quantum world. But humans will always be, I believe, the nexus of accountability, which means there's a role. Humans will always have to own accountability for something. How they accomplish that role will change.
Okay. It's interesting, on our pre-chat, we spoke about this because it's something that Alex and I often use when we're trying to talk about innovation or frame a room and saying, that there's value of looking back into the past to learn lessons, but also we want to think of new solutions to new problems. And it kind of comes back, the younger people or the people who aren't anchored on existing solutions will look at things in a different way, and there's value to that. Do you think we've really seen it all before, or is there new things to be played out? And the one kind of area which I think we haven't discussed yet, which is maybe another fourth strand to layer into this, is the geopolitical additional sphere of the space race that will be played out again in a matter of time. Is this genuinely new for us, or is it just war and politics? Things are going to apply in a slightly higher altitude.
There are things that are genuinely new. So blockchain, you could argue, or even so, internet, using technology to solve the problem of labor mobility. Arguably not new. Lots of business, individual business models, completely new. When we talked about some of them. Some things, some innovations are genuinely new. The best one I can think of is birth control, contraception. Giving women agency. That there's no historical precedent. I predict the future by looking at the past. Nothing is entirely just a retread. Most innovations have antecedents in history that resemble it close enough that you can predict what's going to happen. So for cryptocurrency, you've got the banking deregulations of the 80s. Both in the US and the UK, they changed the laws so that anybody could literally print money. And as a result, enough people got burned that rules changed so that only the government, so money wasn't issued by governments. It was issued by banks. That's why they're called banknotes. That changed as a result of experiments with deregulation, and people said, no, we want the government to issue money. So if you want to understand what's going to happen to cryptocurrency, there's a historical antecedent. If you want to understand, sort of regulation and around AI, actually the most interesting historical antecedent is the technological conversion of global logistic networks from sail to steam. If you look at what people were saying in the press, in Congress, in Parliament, they were saying, it's not safe. People are going to lose their jobs. Am I going to get sued? A lot of these same questions. So I would argue that most innovations have antecedents or innovations in the past that were similar enough to give us some clue of what's going to happen. But there are some that are completely new that we couldn't predict the impact. And the best example of that is contraception, because it gave women reproductive agency rather than being solely under the power of men who were physically stronger and social structures who robbed women of agency. Nobody could predict what the social impact. There's no historical antecedent for women getting that kind of agency. So it was completely new, and we're still sort of working through the societal changes that came out as a result of that technology innovation. So I would say most are old, but there are some net new ones.
Great. I mean, Areiel, we got to start wrapping this up. I've got 1,000,001 questions left, and I feel like there's at least another episode to be had here. I mean, just to riff in terms of some ideas that are popping in my head, I'd love to get your thoughts on the space race and where that's going and what that looks like to be a human left on this planet potentially. Your thoughts on universal basic income, the wealth divide in this new world, and the power that comes with these new technologies and owning them. I think we've touched a little bit on the kind of the races the technology races and arms races that follow. I'd love to get your thoughts on the technology of the people trying to beat death and live forever. There's obviously huge impacts there as a species if we manage to achieve that. And I just wanted to open it up and say, if there were other exciting technologies that you're coming across that we haven't covered, but I appreciate they are episodes in their own right. I guess let's kind of summarize this. Is there anything else you want to say or consolidate on?
I have a thought just in response to what you just said. Instead of getting me onto, I mean, I'm happy to, not that I'm perfectly happy to appear on another episode. This has been a lot of fun, but I'm just one person, and in some ways I'm a dinosaur, and in other areas my opinions are outliers. What might be a really interesting way of exploring the topics that you just raised, instead of just doing a podcast like this, to do a symposium, and I mean that in the classical sense of the word, where you get a group of, say 6 to 8, not much more than that, because I think it gets too hard. But if you got a group of people to dialogue about that, it would potentially be far more interesting than just listening to me or any other one person.
Well, we're a complete sandbox for opportunities. Absolutely keen to collaborate. I mean, if you've got the right 6 to 8 people to put in a room, and Alex and I are happy to represent the general society, so that would be great
Well,
fun.
I definitely know people I would want to bring, but I'm also too old and set in my ways. I think that you may want to
Well,
bring
let's take that
different
offline and
people
make it
well with
happen.
it.
Let's do something. We run these innovators breakfasts. They're always themed, and we open them up, but we'd essentially run that format online for a closed group of people that would love talking about this sort of stuff. I mean, Alex, have you got any final points before we wrap up in our usual fashion without opening too much of a new tangent? That's the problem.
No, not unless we've got another 3 hours. So I think we'll wrap this one up. So in classical tradition, we have kind of a closed question that's asked for the next guest. And I mean, this kind of podcast theme was futurism and all things emerging tech. So the question to you would be, if you have or you're left with whatever you're about to say now in a capsule to society in 100 years' time, what would your message be?
I guess in the context of this conversation, I'd say, if you want to know what's going to happen in the future, look to what's happened in the past. I think that's a fundamental truth that will be true in 100 years, as true in 100 years as it is now.
Thank you so much for your time. This has officially been my favorite episode, and I feel like my burning questions have been well and truly answered with expert depth across all 3 areas. So you're a rare person, Areiel, and it's fantastic to have met you and an honor to have had this conversation, quite frankly.
Well, it's been a delight. I'm very happy to do this and to participate in some of these group conversations going forward.